Each SOTAS may work both FITDMA and RITDMA access modes. Automatic AIS message, like message 6 or 8, as allowed IALA20100325, created by authorized users, can be transmitted from AIS-18 device. Also, numerous synthetic or virtual AIS-18 virtual AIS navigation can be generated intentionally. Specially designed system software controls the SOTAS and connected peripherals. VDR channel carries both nearby AIS A2N message and collects local AIS traffic information for only analyzing purposes. Software is based on client-server architecture and use TCP/IP protocols. One application server is for security services, and the second is allocated for SOTAS messaging processes. Remote monitoring center, including web, database, and application servers with the redundant architecture. Authorized users can monitor the A2N over the downloadable and scalable S57-based maps. Two database servers are for redundancy, and the background smart server architecture can talk with whole register service and application over network. The human interface of the system is our developed software for remotely monitored A2N and analyzing shit around the A2N. We could stop receiving VDR message, depend on type. We may configure guarding of A2N, and we can create a safety related message like message 12. Authorized user can easily reach all the control function of A2N with the remote control software via web. Finally, assessment of gain and conclusion. AIS A2N project of Turkey is an investment which is made in accordance with the National Optimization Program for AIDS to Navigation, and first phase has already completed. By using the benefits of advantage AIS technology, a strong trust is made in terms reliability of AIDS to navigation and developments for the compatibility with e-navigation system is targeted. In addition to remote monitoring and controlling purposes, the system can send local AIS message to individual ship or all vessels by benefiting from multi-directional communication through AIS to navigation device, and it can expand the function of a conventional A2N. Achievements obtained in the installed system are considered to be successful examples for flexible and strong application which may be improved based on AIS infrastructure. Dear delegates, thanks to all for your attention to my presentation. Thanks once more.
Thank you, Mustafa. The third speaker this morning is Yongqiang Lu, Section Chief of the Hydrographic Department in Shanghai of the China Maritime Safety Administration. He is member of the A&M and the EEP committees, as well as active in IALA.net.
Okay, thanks, Chairman. And good morning, ladies and gentlemen. Today I'm very honored to present the paper for my colleague, Lie Qiezhen, Fang Jie, Chen Jiali, which come from Guangdong MSA, China. And the name of the paper is the application of monitoring reception of AIS offshore staging system. This paper has several contents. which is forward, method, application, benefits, performance, factors, and conclusion. Great development of AIS in China. JNMSA has realized AIS coverage around Chinese coast by establishing near 19 stations. The coverage of AI stations may range from 30 to 8 nautical miles, or extending to more than 200 nautical miles, in some cases even reaching up to 1,000 nautical miles. This graph shows the configuration of AIS stations in China. And we saw the key factors that affect coverage of AI station is season, weather, radio frequency interface, electromagnetic environment, the working state of station, and others. This graph shows the overlay of AI strip. The coverage is attended to 900 nautical miles, reaching coast of Vietnam and the Philippines. We have two traditional methods to monitor the coverage of AI station. The first one is we use one or more vessels equipped with AI shipbound units to measure range in order to determine the coverage of station and the strength of signals. This method is labor and time-consuming and vulnerable to environmental conditions. Therefore, it's only suitable for assessing the coverage over river or single channels. Another one is we use tool or video to observe one or more AI stations to determine the live coverage and assess the effectiveness of AI station through manual recording and statistic data. This method is also very labor and time-consuming, and the result is incomprehensive. Therefore, it is only used for real-time assessment of AI station. JNMSA has developed a monitoring reception of AIS offshore station system we call the OSENT AIS. OSENT AIS is based on AIS signal tracking and analysis and flows statistics in accordance with relevant international standards on the definition of AI strip reporting rate. The system calculates AI signal reception rate at every point on chart and provides different coverage of AI signals with different colors. And the system uses a large amount of data in 5 years, which are stored in AIS database. And the system is of C/S structure that consists of servers and terminals. The server is responsible for data extraction, analysis, and storage. Terminal is the interface with user and provide the results. In order to achieve load balancing, two servers are used for calculation. Terminals provide full data retrieval from corresponding server according to configuration. And this graph shows the network of systems. We have servers to description the workflow is to read off real-time data and save them by the hour, to reserve AI data according to the standard, to set up database for each region monitored, to calculate the signal coverage of each reporting point based on the relationship between ship speed and the reporting rate at that time, to calculate the average coverage of every point in chart, and then store the data in the corresponding database. And this table shows the computational algorithm. The terminal to choose the scope of charts, to choose time range for statistics, to request the server and download the corresponding data to show the results. And the workflow of interaction, the client requests to the server through TCP/IP. Server retrieval data in corresponding maps, and the client requests to generate data file and store them in